Hey guys, George from SoundTraxx here, and this week we're going to go back a little bit to the basics. Now I know we've talked about addresses in the past before, but since I've been doing the support calls for about the last week or so, I've noticed there's still some people that don't quite get the addresses, and so they're having problems setting them up or whatever. Is that you? Well, let's talk about addresses and dive deep into how the addresses are formed, how they're used, and what the purposes are, and any problems that you may have. So let's get started. Now, first off, when you open up your decoder, every decoder through the DCC system, now I don't have any track here in front of me, but every DCC system sends a command prefaced with an address. Now, the address is like your mailing address at home. It's who the command, in this case, is intended for. And so when you're sending out a command on the main line or out to your locomotives, you set in that you're controlling locomotive number X, whatever it is. And that address, or that command, is then generated into a command that is prefaced with an address. Now, we're going to dive a little deep into addresses. Now, first off, when you open your decoder, every decoder that we ship out is defaulted to an address of 3, which means you simply grab your throttle, you select Loco 3, and hit enter, and you should be able to control your locomotive right out of the package. Now, this is what's known as a basic address. And the basic address, also known as a short address, some companies use 2-digit lingo, 2-digit address, and those type of things. But basically, the short address, 2-digit address, or basic address is a number between 1 and 127. And that way, basically, the command would go out, hey, everybody listen up, Loco 52, move forward, speed step 10, turn on F0, turn on F1, turn on F4, whatever, and end of transmission. And then now, these 3 locomotives, locomotive 52 would be the only one that would respond because that's what we've set the decoder to. Now, the short address or the basic address is stored in CV1. And as I mentioned, is a number between 1 and 127. Now, there are some systems out there that actually block and limit certain addresses. For example, DCC calls it a 2-digit address. And so when you get into address 100 to 127, depending on the system, you can actually get into a no man's land where you can't run or control your locomotives. Now, this is, I believe, been rectified, but early systems on, especially as the advent of the Santa Fe Superfleet, when they were resurrecting the red and silver, the GP60s were in that 100 to 127 series. And so a lot of times that address would be blocked on some of the DCC systems because it wasn't technically a 2-digit address. And that was how they differentiated it. But now the other type of address is what's officially known as an extended address. Other terms you may have heard are long address, you've heard 4-digit address, and things like that. And a lot of times now with the more modern DCC technology, they've actually expanded it out where we can actually use the locomotive cab numbers. And so here you can see this Pittsburgh Lake Erie is 8663, and then we have also this Conrail over here is number 4125. So that way it makes it nice and easy for us to remember which locomotive we're talking to. Because prior to the extended address in DCC, addresses 1 through 127 is all we had. So we had to find aliases. And so in this case, 8663 could be 86 or it could be 63. And then depending on the system and how the person wants to operate it, they could decide what it is. It could also represent their club member ID number or something like that. But that way they knew that was their locomotive. And that was how they addressed it. But then when they opened it up to extended addresses, now I don't want to get too confusing here. This has been on for quite some time. A 4-digit address has been a long time, but the very, very first DCC systems only could talk to the short or 2-digit addressing. But with the 4-digit addressing, of course, we can open it up. So now when we talk about the long addresses, the long address or 4-digit extended addressing can be a number between 0001 and 10239. But again, a lot of systems may limit which ones you're actually able to talk to. Most systems will top off at 9,999 because most of the times, most railroads don't use 5-digit numbers on their locomotives, so it becomes somewhat superfluous and not needed. But when you're talking about the DigiTraxx and 2-digit addressing, sometimes that's where they were blocking out any of those address 0001 to address 0127 as only 2-digit addresses, because then that way you couldn't conflate the two. And when you selected it in your throttle, there was only one option. However, NCE allows you to talk to both. So whether you're talking to address 3, which is the default, or if you change CV29, we'll get to that in a moment, to actually enable the extended address before you set the address, the decoder is defaulted with an address of 0003. And in NCE, when you put any preceding zeros, that tells the control system that you're talking to the long address 0003. Now, you and I see 3 and 0003 as the same number. But the difference is the way it's written digitally through the ones and zeros that are transmitted through the rails, that 3 and 0003 are formatted differently so that way you can have those both active addresses on your layout, including 52 and say 0052. And that gives you some flexibility, but it also means you have to pay attention to what addresses you're actually using. So the first question is, how do we set the address? Well, the basic address or the simple address is very simple. It's actually stored in CV1, and it's a number between 1 and 127. And so when I go to CV1 and try to change it to a value of 52, I can do that on the programming track, no problem. Pick it up, put it on the track, select loco 52. My locomotive is going to run all day. But when it comes to these extended addresses, they're a little bit more complicated. You would think it would be easy to just put 86 in CV17 and 63 in CV18, but it's not that easy, unfortunately. So the good news is most DCC systems do this calculation for you. If you want to double check that, you can also go online and find many address calculators that you can actually type in your desired address, and it will do the math for you. But just so you know and understand what's actually happening, so if we're going to take our address that we desire, we're going to add it to the number 49152. Now, don't blast me in the comments. I'm not the engineer, so I can't tell you why, but this is how it works. So you take your address number, you add it to 49152, then you divide it by 256. And what you do then is you take the quotient, which is the whole number, and put that into CV17, and then the remainder, which is if any of you guys go back to elementary school math, is the remainder of what's left over. That's what's stored in CV118. So for example, let's take address 7152. No, I don't have that on my table, but I have it on my handy little notes sitting off to the side. But anyway, we're going to take address 7152. So we're going to add that to 49152, and we're going to get a final number of 56304. Now we're going to divide that by 256. So our quotient is actually going to be 219, and the remainder is 240. So we're going to take 219, we're going to program that into CV17, and then we're going to take 240, program it into CV18. So that way your decoder knows the address is 7152. So let's just try another number. So you guys have heard me talk about address 1000 a lot of times when we're talking about DCC and how things work. It's a pretty easy number to remember. So we're going to take address 1000. So we're going to set address 1000. We're going to put that into, add that to 49152, which is going to get us the 50152. Now we divide that by 256. So our quotient becomes 195. And the remainder becomes 232. So we programmed those into CV17 and 18 respectively. Now the biggest thing to remember is that the extended address is not active at that point. You've simply changed the numbers. And so that's when we have to look at CV29. So CV29 will either enable the short or 2-digit basic address, or CV29 will enable the extended long or 4-digit addressing. So it really depends on which one it is. So once you set your address, you'll actually go in and make sure CV29 is set properly to make sure that the proper address is enabled. Again, the good news is most DCC systems will do this work for you, but it's always good to double check. Now, here's some questions and some things. Now, over the last week or so, as I mentioned, we've had some people with some troubles with addresses, and so I want to cover some of the common things. First off is when you're on the main line and you're actually operating your locomotive, you cannot make changes to the active address. What that means is, let's use example 52 here. So if I'm running on address 52 and I decide, you know what, oh, somebody else is coming in and they have 52 also. Don't worry, I'll set mine to 53 or whatever the case is. I can't change this address to 53 when I'm on the main line. I cannot make changes to CV1. And then same thing with the extended locomotive addresses. If I was on the main line operating, I can't make changes to the active address. So if this is 8663 and I want to make it 8664, I can't do that on the main line. The reason why is it doesn't want you to accidentally lose control. Now this is an NMRA recommended practice. Not recommended is suggested, not mandatory to pass the standard. But the recommended practice is that you cannot change the active address. And why is that? Well, with over 500 CVs built into our decoders, it's easy to get into a haste when we're pushing buttons and accidentally, let's say we're programming CV51, I want to change a lighting effect. And when I program CV51, let's say I hit the 5 but it doesn't actually take, then I press the 1 and it takes, and then I hit enter. Now I enter my value and press enter. Well, now I've just made a change inadvertently, unintentionally, to address or to CV1, but I was trying to change a lighting effect. And so why did I lose control of my decoder when I was changing a lighting effect in my mind? And that's the kind of stuff that can make things a little intimidating. So the good news is you can't make changes to the active address. However, that also means that if you're intending to make changes to the active address, you cannot do that on the main line. And so that's where you can go to the programming track and actually set your address. Now, you can take an address from, say, 52 to 5200, because that's taking it from a short 2-digit address to a long 4-digit address. So that type of change is allowed because it assumes it's intentional. And some systems will walk you through the prompts as you type it in, and again, it will automatically do it. NCE, for example, will automatically enable it. DigiTraxx, you have to push it says enable this address, you want to say yes really quickly, and then it will enable the address. Now, other times we go to the programming track, sometimes third-party programs, or maybe sometimes a button doesn't take and you don't set the address properly. Well, that's nothing the decoder did. The decoder is going to work no matter what you do, as long as it works. And so you can change CVs all day long, but it doesn't mean you broke the decoder. What likely happened is you probably typed the wrong address. Guess what? You have 2 ways of resolving that. First one is leave it on the main line, select address 1, see if it works. Select address 2, see if it works. Select address 3, see if it works. Until you get all the way through and one of them will work, or the other option is you go all the way up to 9,999. And then let's say you're talking to the wrong address type, and so therefore now you have to go back and start again with 0001, 0002, and so on. But the good news is you can do all this on the programming track, and you don't need any boosters or anything like that with any of our current products like the Econami, Tsunami 2, or the Blue Nami. Now, the other thing that can happen is, and I know this is real common with NCE, is if you type the preceding 0 and type in your 2-digit address like 52, on your screen, you're going to see *052. And what that's telling you is you're actually talking to the long version of address 52. You're not talking to the short version. And so what happens is no matter how much we will the locomotive to take the command, since those addresses visually look the same but are digitally written different, the decoder ignores the command. And so therefore, you can set address 52 and have 0052 as an active address on the layout, and neither of them will get each other's commands. Now, again, one of the other things we've talked about, CV29, you want to make sure that that has the proper address enabled. And then the last thing that can happen occasionally is when you're running a locomotive as part of a consist, let's say, and we go in and we set CV19 as we're building our advanced consist. For more information on advanced consist, be sure to watch webinar 14 on our YouTube channel right here. But when we build our consist, we set CV19, and that tells the decoder that it's running under that command. But if we take this locomotive out, we have to make sure we set CV19 to 0. Because what will happen if we don't is if we select 8663 and we blow the horn, ring the bell, the decoder is going to respond just fine. but all the motor commands are blocked because the decoder thinks it's consisted with this other locomotive. But when we set the address, or when we try to run it, it's thinking it's part of it, so the decoder is ignoring that command and not performing. So again, it may look like the decoder's misbehaving, but it's actually because CV19 got set to an address. So if you have this scenario where functions work but the motor doesn't, go back and double check CV19. Now, for those of you NCE folk that use the NCE style consisting, even though I don't recommend it, I recommend actually learning the true advanced consist, because the NCE style advanced consisting does set CV19 in the decoder unbeknownst to you. And so therefore, if you pick it up and take it to another layout, you have no idea to know what that CV19 address was until you go set this to CV19 to 0. Now, these are just some of the things, and the really deep dive into addressing. And I know it's a lot of information, but addressing is decoder 101. This is something that's been around since the beginning of time, of DCC time, I should say. And so if you're having problems setting an address, take a breath, put it on your programming track, which is where you have that isolated, controlled environment where I can talk directly to the decoder. And that way you can go in and set the address properly to make sure. And then you can also go back and read the CVs to make sure that the value is correct. So now that you know the formula on how to set the address, you can also double check to make sure that CV 17 and 18 are set properly. Then you want to go into our user's guide, and there's a full page chart on all the different CV 29 values to help you make sure that you're enabling the proper address. So guys, that's everything I've got prepared for you this week. I hope this has been helpful for you. If you have any questions, either leave them in the comments below or send us an email to support@soundtraxx.com, and we'll be happy to help answer anything we can. We're here to help you. We want to make sure you're enjoying your SoundTraxx products. So that's it for this week. We'll see you guys next time.